These are the manifolds, differential geometry, measure, and intelligence chronicles. Welcome. My name is Subhashis Mohanty. Intelligence here refers to artificial intelligence, as no doubt many of you have surmised. A less than perfect term apropos of its practice, but nevertheless. Intelligence, yes, it is the zeitgeist, the spirit of the times. But why study manifolds, differential geometry, and measure theory? Data in many disciplines, AI, computer vision, social networks, financial markets, are high dimensional and can often be assumed to lie in manifolds, whose characterization is aided by differential geometry and whose sizes and abstract volumes calculated by measure theory. Thus, their study can give us valuable insights about data that can inform decision making in business, government, and research. Besides, there is an ancillary benefit that might appeal to some of you. A great many scientific advances of the last few hundred years, general relativity, quantum mechanics, quantum field theory, electromagnetism, become accessible with this toolchain. The various realizations of these chronicles, short and long formats, subscriber and free modules, can be found on YouTube, Substack, and Instagram at these URLs. Additionally, you can also join the discussions on Discord. My focus will be exposition and practice, abstract, hands-on, but always tears-free. How? Mostly following 2024 Abel laureate Michel Talagrand's nod to physicist Brian Hall, whose approach is to describe a theory in complete detail, starting from the basics in a language the reader can understand. Thus, I shall proceed languorously, unhurriedly, as that is, I believe, the path to deep understanding. Deep understanding and thoughtful and effective and efficient and correct application. Examples, proofs, code, diagrams, animations, and exercises shall be the foundation and substance of these chronicles. 3 indices. I shall use 3 indices, episode number, topic number, and not shown here, concept number, to help us navigate these chronicles easily. Also, 3 vignettes. I shall present 3 vignettes to you at the outset so that you can decide if you would like to follow these chronicles. These vignettes will be as concrete as the introduction was abstract. Which you should view first, step back and look at the big picture in the introduction, or lean forward into the details of the vignettes is a matter of taste and temperament. Both can be found in this playlist for your discernment and perusal. So what are these vignettes? The first vignette, some mathematics. Some mathematics to get us, we the engineers, we the recently liberated engineers, as in the introduction, started on exploiting our prodigious and surplus prowess, as in the introduction, towards 2 overarching goals. Goal number 1, piercing and upgrading and making current AI more robust. And number 2, understanding mathematical intelligence as a step towards AGI, artificial general intelligence. The second vignette, some Python code to start laying the foundation and infrastructure in support of the ambitions in vignette 1, and also an application that uses the latest tools, frameworks, and foundation models to solve the math problem. And finally, the third vignette, some lean code, some code in the lean system to aid proof checking and also as grist for the ravenous AI mill. Ponder this: mathematics, engineering, the use of advanced mathematics to solve engineering problems. Also, the use of engineering to solve math problems. After all, we will be using tools, frameworks, and models to solve math problems. Also, the engineering of mathematics. Lean code, the proof checking and proof assistance, is a type of engineering of mathematics. So here we have engineering, mathematics, the mathematization, if there is such a word, of engineering, and the engineering of mathematics, all intricately interconnected. And I hope that we can use this to make advances in both mathematics and AI.